Good morning. This is going to be our first lesson out of the new textbook, which I'm excited about because it's way better than Eureka Math. And by now we've done some reviews, and you can kind of see that we have this warm-up all the time on every lesson that we have. These are really important because even though we hate word problems, most kids do, they're the most important ones. And so what I'd like for you to do is to kind of look at this problem here, come up with an answer, and respond down here under letter A with your answer, and then we'll talk about it. So pause your video, read this math problem, and give me an answer here. Alright, so welcome back. We're talking about Cindy and Victor here, and they said we both won on this tic-tac-toe game, and so you have to remember back from junior high days what a rational number is, and we're going to review that today. But you'll see there's a lot of reoccurring themes in math that from junior high days we expect some kids to know these things and remember them for the next several years of their math career. And so we think back to a rational number, which again, we'll review this today. A rational number is any kind of a fraction or a repeating decimal. So if we're looking at Cindy right here, she says, hey, you know what? I'm going down this way here. That's a decimal. That's a fraction. And a whole number, or a natural number, is a natural number will fall into that category too. So I'm going to help you with this today and show you how to do these things. So Cindy's right. And then if you look at Victor, he said, oh, I had all positive numbers. You probably got this one because if you look at Victor right here, he says I have all positives. Well, pi is 3.14, which is a positive number. Square root of 10 is an irrational number, but it's also a positive because I don't see a negative sign in front of that. And then I see a positive number here called 1.3. So I'm hoping you came up with something very similar to this, where we're saying, yeah, they're both right, and then kind of explain it. Okay? So let's get started on today. Okay. After that warm-up, we'll always talk about what our objective is. The objective is, by now you've had several days of school, what we should be able to do by the end of this lesson. And you have to put some ownership to this. We need to know about operations with real numbers, and we need to know about these things called element of a set, what a real number is, a set, and a subset. So these notes are going to be your go-to when you go to do your homework. You should have these guys out while you're trying to do your homework because this is what you're going to keep referring back to until you can do it naturally. Okay, so use these notes. A lot of times in years past, kids would do the notes because Mr. Fisher makes them do them in class, and then when they go to their homework, they don't even open their binder for the help to help them when they get stuck on math problems. Every example that's in our notes will also be on your homework. Okay, so I put a lot of this in because this is in your textbook and it's important information, important enough that I think it should be in your notes. Your textbook is online, so it's not a very good resource to have online and kind of keep clicking back and forth to help you with your homework. So we're taking a lot of paper here and a lot of copies to try to make it successful for you. So again, use these notes. When we're looking at some of these examples, you'll see that there's no work here. It's just kind of explaining some things. And so what we'll do in class is we'll probably read through this thing and talk about it. Okay? So we still don't sometimes know what an integer is, so we'll talk about that in a second here. But a set of integers from 1 to 10, which the elements are both the subset of even numbers. And the subset is a multiple of 5. So this is what we call a set of numbers here. The first rule they're talking about. So they said numbers between 1 and 10. They said right there, okay? Now, when they talk about a subset, there's usually a rule. So these are what we call subsets down here. And so they'll say something like this. They'll give a couple numbers here, and then sometimes we have to figure out what it is that they're trying to do. Or sometimes they'll tell us the rule. And so it looks like all these numbers that are down here are even numbers from this set up here. And so if we just had these numbers listed right here, well, then we have to figure out what the rule is. Sometimes they'll say, hey, I want a subset of all the even numbers of the set. So then we would write brackets like this and say 2, 4, 6, 8, 10. Okay? And then we have another subset of a subset, another subset here they say 5 and 10. Well, as I'm looking at these numbers up here, 5 and 10 are two numbers in there, and we got to kind of figure out what the rule is. And so if we think about it, well, 5 is a multiple of 5. 5 times 1, and 5 times 2 is 10. So then the rule would be listed like this, multiples of 5. The number 10 is the only number in the element that's in both sets. Okay, subsets, I'm sorry. So there it is right there. So if we had another subset, and we said, well, let's look, what's the subset of B and C? Well, then we'd say it's 10. So every time we go down, it's called a subset, okay? All right, so now we're on the you try it. So this is where we use our whiteboards. Again, we've been in school now probably for 7 days. That you should be kind of on top of this, okay? And so we pause the video when you're not in school and then do this, give it a shot. It's okay to make mistakes, but we learn from our mistakes, okay? And so we're looking for numbers in the set A that are elements in both subset of odd numbers and subset of multiples of 3. So there's 2 rules there. We're only going to have one answer here, unless you want to make the subsets here. But here's my 2 rules. I want a subset of odds. So we could do it this way. Pause and write all the odd numbers. So that would be 1, 3, 5, 7, 9, and 10. So there's our first rule. And then our second rule is a subset of multiples of 3. Well, this next subset would be 3, 6, 9. We can't say 12 because 12 isn't in there. So now there's our 2 sets. Now most kids can do this in their head, but because they said make me that's a subset that's in both of these rules, I'm going to look for now numbers that are in both of these categories, which my final answer is going to be in brackets. That's how you record subsets. And it's going to be called 3, because that's in both, and 9 is in both. And there's my answer. I'm going to put a box around it. Okay? So some kids can do it without making the list of both subsets here and keep the rules in their mind, because usually they don't do more than 2 subsets. Okay? All right. So that's kind of pretty easy, I guess. All right. Now, so there, whoops. Oh, I missed one. Probably shouting, you're right. Let's see, 1, 3, 5, 7, 9, 10. No, 6 is not an even number, so this answer is not right. It's just 3 and 9. I want to fix that guy. Sometimes I do these videos in the morning when I make this. I'm not quite in tune yet, so I want to erase this and just put 3 and 9. In my first hour class, they better kind of let me know about these things, okay? All right, so normally I have this, we do it on the whiteboard, you give me this answer, and then I go around checking things, and then just because sometimes I'm helping kids, I get a little bit behind, and so I'll have the answer on the next one. Don't get into this habit of you just know that Fisher's going to roll up the answer here in a second, that's all I care about, I don't care how he got it, I just want my notes done, 3 and 9, but I don't know why it's 3 and 9. Really get into this position of it's your job to learn this stuff. As much as I hate to say that, I'll be here for a number of years, but you got to have these math skills in order to continue on to the next level in math. Okay, you've probably seen this chart. It's on my wall as well, and you see a chart often like this that they said, hey, you know what, these are all real numbers in this box here. Whether all of these numbers that you see right here, they're all called real numbers. So there's a freebie. If they ask us to classify numbers, every number up to 9th grade is real numbers. Now when you get to higher grades, they'll have other things called imaginary numbers and things like that that we have to do with math. But right now, that's a freebie. Every number is a real number, okay? So we started out in 1st grade with these guys, 1, 3, 5, counting numbers, and you counted on your fingers when you were in preschool, and then you decided how to count up. And so I'm going to make a chart, and I'd like for you to make this chart over here too, because we started school with natural numbers in kindergarten. I can only imagine if they said, hey, what's a -4 in kindergarten? Your little eyes would say, I have no idea. So natural numbers are counting numbers. I want to put them here, just so I have some examples here. 3, 5, 112, just a couple there, okay? And then teacher said, well, you know what? If we took all the numbers away, we have another number, and the only one that's in this category is 0, and so we call this a whole number. Now, a whole number, this 0 is the only one that is added to the group, okay? All right, and then we went to 6th and 7th grade, and we said, hey, you know what? We have these things called integers. And this was a group of numbers that was added that was all negative numbers. So like -3, -12, -1,314. Any negative number is an integer, okay? There's other ones, but we're going to talk about that here in a second. And then we went to these things called rational numbers. And rational numbers are fractions. Like 1/3. It can be a repeating, so I want to put that down here. Repeating, which 1/3 is a repeating fraction. Okay, 1/3, 1/4, but it also can be decimals. 0.25, 0.5. So anything that's a decimal or a fraction or a repeating fraction or decimal is a rational number. Okay. Now over here we have what I call the weird group, and that's why this box is over here. These are irrational numbers. My handwriting won't get better. This is my first video this year. Irrational numbers, and so irrational is very important. Never decimals that never end. And don't repeat. So this is why it was important when we were doing how do I use my calculator at the beginning of the year, because if I said the square root of 3, that's an irrational number, and it shows me square root of 3 on my calculator, but if I make that into a decimal, I see 1.732050808, and it just keeps going on and on and on forever. And so this is my example here. Square root of 3 comes up often. Pi is always one that comes because pi never ends. Square root of 7 is an irrational number, okay? And so these guys, now, this is how my chart helps me. Because if they said, okay, let's look at -5. Well, -5, as I look here, it starts right here. And so it starts with an integer, but all these numbers will fall down to the category below, to the next level down. So -5 is not only an integer, but it's a rational number as well, okay? And so they should have a real number here as well. So I want to put that here because all numbers are real numbers. And you'll see that on your homework, that sometimes they put it in there, sometimes they say, well, you know, since we all know numbers are real numbers, we're just going to leave that one out. We'll just say, hey, you know what, it's an integer and a rational number. Let's go to like the number 3. This is again why I like this chart versus this one. But once you see this pattern here, this one, you'll know how to use it. It's like a top view looking down on the cake. So if I said, what's all the numbers for the number 3? You know what, I'm going to add real number up here right now while I'm thinking about it, because the big box is real numbers. And all numbers are real numbers, okay? So I'm going to put that up there, because all these guys are within that big box. So, if I said the number 3, and they said classify it, I would say it's a real number. I like that one first, because all numbers are real numbers. So that's a freebie. Even if it was an irrational number, it's a real number. So 3 starts right here at the natural number. So it's a natural number. But because they fall to the next category down, 3 is also a whole number. It also falls down into the box called integer. And then it falls down into the box called rational number. So there's a whole lot of them. And so if you just kind of go in the order and remember this order, then you're A-okay. If I said, what's the number 0? Classify the number 0. Well, 0 starts here. They can't go up. So it starts on 0. So my first one would be real numbers, because all numbers are real numbers. Then I would say whole number. Then I would say integer. And then I would say rational number. If they said, well, classify the square root of 3. Well, 3 is right. Square root of 3 is over here. It can't go over to this pile over here. And there's nothing underneath it. So it's a real number and it's an irrational number, and that's it. All right. So if you see this pi, and I draw this on my paper sometimes when I'm doing rational numbers or classifying numbers, but when you do your homework, until you kind of get this pattern down of the order over here, use your notes. Okay. All right. It's on my wall over there, so you really don't need notes during a test or a quiz until you learn it and memorize it. So here we go, 0. So they said for each number describe the subsets. So we're going to start with 0. So if you remember back to our pi, it starts out at whole number. Oops, I want to go up one. I want to put real number up here. And some kids will do this. They'll say real number. And they'll say real number. No matter what it is, it's always a real number. So we're kind of cheating here a little bit. But not really, because we know all numbers are real numbers. So 0's a real number. It doesn't start at the very top. It starts at whole number. And then the next one's down going to be called integer. The one underneath that one is called rational number. And so just kind of use that pi up on the top of above there to help you with that, okay? All right, so whole number, integer, rational, and that's it. There's nothing underneath rational numbers. All right, you do these two real quick. Let's see how you do. All right, let's see how you did here. On number letter B, did you say it was a real number and then irrational number? Because if you go back to your pi, which we had square root of 3 right there, it's an irrational number, but it's also all numbers are real numbers, so it has two names right there, okay? Again, I like to write real number first. This guy, now some kids will make this mistake. They'll say it's a -1/9, and so they'll see up here the negative sign. They say, hey, you know what? Negatives start right here at integers, and so if you accidentally listed integers, well, the fraction comes first. The number is a fraction that we're looking at, and then it's a negative here, okay? So it's not an integer, but it is a fraction, so it's just a real number and a rational number, okay? So that one's a kind of a tricky one. You just got to kind of remember, we're looking at the fraction part first, and then we'll look at the negative sign saying, well, you know what, since it's a fraction, that overrides the negative part, okay? All right. Now, this is where things get a little crazy, because, I don't know, nobody really asks you this, but it is kind of important in math as we go through here. You got to know what a rational number is. So now this is kind of like the 9th grade part. Remember, rational numbers are fractions. So here's my fraction. And they said, hey, you know what? Let's make a rule. And they said, is the sum a rational number? There it is. And an irrational number, so that'd be like square root of 3. And when I add these guys, because sum means add, you might write that there if you don't know that. Sum means add. If I add these two numbers together, am I always going to get an irrational number or a rational number? And so, let's check this out. Now, they always use in algebra little things like this, but if I was taking this and I was getting that C by itself, I would subtract an AB from both sides to get this over to this side, okay? I'm just going to put square root of 3 here, just as an example. Now, you should know by now that when you're adding and subtracting fractions, you need a common denominator. So my common denominator, when I put these two guys together, is going to be a QB, Okay, doesn't matter which order. Usually you put them in alphabetical order. But when I put this over here, I got to have common denominators, and so I'm going to multiply that p by a b. Right there it is. And then that a is already over here, so my common denominator is going to be bq and a minus aq. So this gets a little bit hard. But if you'll grab your highlighter, here's the important part. Down here is the important part. So the sum of a rational number and an irrational number is always going to be irrational, always, because I still have my irrational number. Even though I have over here a rational number, a fraction answer, I still got my square root of 3 over here. I can't make this little guy go away by itself. Okay, it's always going to be an irrational number. Now I'm also going to tell you to do this. Not only write sum, but this also works for differences. Okay, so sum and differences, we're always going to be looking for common denominators, and we're still going to have a rational answer over here when I put this guy over here. But this guy is always going to be an irrational number, so I'm going to write always as well here. So rational number and irrational will always be an irrational answer. Okay, so this guy here is the one you're going to see on your homework. You got to know a rational number is a fraction. Irrational numbers like pi, square root of something. Now if I said square root of 4, whoops, that says 9. By now in school, you should know the square root of 4 is really not an irrational number, even though I have the square root sign, because the square root of 4 means what number times itself 2 times will give you 4. Well, that really equals 2. So you have to be a little bit careful here about this and when they give you numbers, okay, and say, well, here's a number, is it always going to be rational or irrational? You have a little bit of math to do, okay? All right. So try to be careful with that one. Now here's another one. They're talking about products. Now if you don't know or can't remember because it's a big summer, product always means multiplication. Okay, so they said, what if we multiply a rational number and an irrational? No. Now for me, this is really challenging for me because I know what these two guys are, but it's really hard to explain it when I have the A's, B's, and C's here. So I'll do my very best to help you here. But this is really kind of crazy. So what the rule says is if I have a rational number, it's a fraction, and I want to move this guy to the other side, what we normally do is we flip this, as we learned in junior high. We flip it and multiply both sides by that. What I do to one side, I have to do to the other one. So I have a BA over here. And so now I have this QA down here and a PB up here. But again, we still have this irrational number here. Okay, so it's still, even though we have a fraction over here, which is a rational number, we can't get rid of that irrational number over here. Okay, so now we're going to come down here, we're going to grab our highlighters one more time. So the product of a rational number and an irrational number is always irrational. Okay, now we're going to put also another word here because the opposite of product is quotient. And quotient means division. So this works for both product and quotient. Because we're going to do the same thing. If I divided this fraction here, I'd flip it and change the sign to times here. Okay? Now, here's a little bit of a but, you might say. Unless, this is very important, the rational number is a 0. So this rule works. The product of a rational number and irrational is always going to be irrational unless the rational number is 0. Because if I said this is 0 here, well, 0 times any number is 0. So if I said this is still square root of 3, well, 0 times square root of 3 equals 0. And 0 is a whole number. So it's not a rational number. Okay? So it's not a very hard rule to kind of memorize. You just got to know on product and quotient, anytime it's a 0, well, then we're going to have a rational number because 0 is irrational. So again, I would highlight this because that's important when you do your homework, rational and irrational. Now, let's talk about this. Is the difference between a rational number and an irrational always irrational? So difference, you gotta know what that means. Okay, give me your answer. And they say explain, so you might have an example there. Okay, so this is the hard part, and this is the part that kids don't like. They know the answer, but they don't know how to explain it. So let's see how I did. So pause your video, give your answer. Your answer is probably not going to look exactly like mine, but it should be very similar. Okay. All right, let's see what I did. Well, I used that square root of 3. Here's my rational number, fraction. There's my irrational, so I said the difference. So here's my rational number, you have to go in order. Here's my and, so the difference sign goes right there where the a and d is, and there's my irrational number. And so then I just made a number, random number over here. And so to kind of prove my point, I subtracted a third from both sides. Need a common denominator, so I converted it to 12 thirds. Subtracted and I got 11 thirds, but I still have this guy. So it's always an irrational number. Okay? All right, that's a lot there. All right, but with practice on today's homework, you'll see it. Now at the end of each lesson, I try to put in there a summary like this. Okay? Now, let's go over here because we didn't talk about this. This is just back from junior high days. If I have two rational numbers and I'm adding them, well, this is a fraction, this is a fraction, both of those are rational numbers, I'm going to end up with a fraction, always. Even if I'm multiplying a fraction times a fraction, I want to end up with a fraction. Okay, so the rule up here says if I have two rational numbers, it's always going to be a rational number. If I'm adding and I want to put the word subtracting, whoops, can't spell subtracting, subtract. And always the product and quotient, I want to write quotient there because that works for quotient, of two rational numbers is always rational. Okay? Because even if it ended up to 0, 0 will fall down. It's a whole number, it's an integer, and it's a rational number. So no matter what, on products and sums, if I have a rational number and a rational number, it's always going to be a rational number. So this is probably the most important page when you do your homework tonight. Actually, we're going to do our homework tomorrow because I'm going to show you how to get into it and how to record your answers and some things about that. So tonight you won't have any homework. So man, this will be like 24 hours later. You'll come back tomorrow and we'll see how to do this. So these notes again are going to be real important that you have out. Now here's what we just talked about. A rational number and an irrational number is always going to be irrational. Okay? That's always going to be that way. But now if I have products here, I'm going to put this little arrow here because this one's the only one that has this special rule. Only on products and quotient. If I have a product and a quotient where my rational number is a 0, then I'm going to have a rational number. So this one's a kind of a be careful one. So I want to highlight it in pink because I want it to be careful down here, except when it's a rational number is 0. Okay? All right. Now, to be honest with you, down the road, nobody is really going to ask you, hey, you have an irrational number, you have an irrational number, what kind of a number are you going to have? But for tests like SAT, ACTs, which you're going to take in 3 years, you'll take a practice one this year, they're going to ask you things like that, okay? So again, a lot of times in math you'll say, when am I ever going to use this in life? Well, also part of math is, can somebody tell you something and can you work on it and can you redo it and repeat it? And so it's kind of pushing that part of the brain to be able to do those things, okay? So get over the argument. I've heard it for 38 years. When am I ever going to have to use this? This is stupid. Well, you could say that. I agree. But no matter what career you're going to do when you grow up, someone's going to give you some directions, said this is how I want you to do it, and they're going to give you multiple steps, and can you repeat those multiple steps? Whether you're a pilot for an airline or if you're out digging ditches, they're going to tell you, I want you to dig this ditch with a slope of this so that all the water and whatever's in the sewer line goes the right direction at the right place. All right? So there's a little plus. All right, you know what, because we're doing it tomorrow, I had these guys here, so the period's probably going to end here fairly soon. But try these guys real quick, okay? And I don't think I have them on the next page, but I will make sure I do for my class because I want to repeat it. Yeah, I don't think I do. I think I just have it there, yeah. All right, so that's why I like to make these videos in the morning time. All right, look at this guy. Now this is one where a lot of kids are going to say that's an irrational number because they see the old square root sign there. But if you put square root of 200, and this is why you need a calculator now, if I put square root of 200 in there, let's see what happens. It might be in there. Yep, it fills up my whole screen. So this guy is going to be a real number. Whoops. A real number. And an irrational number. But not all square roots are irrational numbers, so be careful. Let's look at this one down here, because you can break this guy up into this. You probably remember this from junior high days. What's the square root of 81? What number times itself is 81? Right, 9. What's the square root of 16? Right, 4 times 4 is 16. So really, even though this is going to become a mixed number, 4 goes into 9 2 times, 1's left over, 2 1/4, this guy here is a rational number. It's a fraction. Okay, it's a mixed number. So this guy's answer would be real number. It will also be a rational number. And that's it. All right. Here's my repeating decimals. I don't care about the negative sign because I look at this part first and it's a decimal and it's repeating. So this guy's going to be a real number and a rational number. That's it. Not an integer. Whoa, this guy's going to have a big list because this is like first grade kindergarten. 17. So that's going to be real number. It's going to be a natural number, whole number, integer, rational. So I hate these guys because I have a whole lot of writing to do on those. Okay, but that's where we started, kindergarten. Let's see what the word problem is, because these again are the most important kind. Give me what you think on this one. They said the park is shown in the shape of a square. Is the perimeter a rational or an irrational number? Give me your best guess and why. All right, hopefully you paused the video, kind of wrote something there. Let's see what this is, because you should know right now that if it's a square, area equals length times width. But if it's a perfect square, and they told us it's a square right there, square is the same thing as one of the sides squared. Okay, so if it was 4, and this was 4, well then the area is going to be 16. 4 times 4 is 16. Okay, so I'm going to do this real quick. And if I took the square root, because I know what the area is, took the square root of 16, my answer, the sides would be 4. I want to fix this real quick. This is going to be a side here. The side's squared. So if I gave me the area, and they did, I can see that right here by yards squared. That means they took something times something to give me this number. So to undo that, what I'm going to do is say, hey, you know what? The area was 24,200 equals my side squared. So the way to get rid of a square is to take the square root of both sides. So now I'm going to say, well, what's my side? Let's take the square root of 24,200. And I'm getting 155.96349. Lots and lots and lots of numbers. So because it's filling up my whole calculator screen right there, because I know on my calculator what a full screen looks like, this guy is going to be an irrational number. Okay, so it's going to be an irrational number. All right. So this is what kids kind of get stuck on a lot of times. It's like, well, I don't know how to solve this. At the beginning of the year, it's going to take some practice. You're going to be frustrated. You're going to ask mom and dad, and your brothers and sisters are going to say, I don't know. But hopefully we kind of try something, and then if we're not right, we kind of figure out and really study or focus in on why that is. And then we can be able to do it with more practice, all right? So tomorrow we're going to come through and we're going to show you how to put your answers in online. So you have no homework tonight. You should be snapping these guys into your binder in order so that when we have our first test, then you're able to turn in your notebook and get full credit. I think it's 20% of your overall grade. So this should be like a freebie A, part of your grade. This should be an A+. Even when you're absent, which we've already talked about this, the videos, I'm going to try making videos. I can't promise it, but I'll try making videos for every lesson that if you were at a football game, away game, and you left school early and you weren't in my class, well, you can still go watch this video and stay caught up. All right? All right, well, have a good day, and we'll see you tomorrow. Gotta figure out how to turn my camera off here. Boy, if that whole thing didn't record, I'm gonna be really mad.